As we are wrapping up 2.3, last thing we're going to do is approximate the mean for a frequency distribution. Approximate means because if we look at our data here, we have populations, the population in thousands of the parishes of Louisiana in 2015. And the source was from the Census Bureau. Notice how we have 0 to 49, frequency is 49. So, you know, we don't know exactly what those specific values are. We just have a range of values. So we don't have the actual concrete data, but just kind of more of a range. So this is going to be considered an approximation because of that. Now, to find the mean for a frequency distribution, again, X bar represents the mean. Let's see if I can mark that there. That's our mean. And then remember, the sigma symbol represents the summation X times F. X is actually going to be, in this case, the midpoints of the classes, and then we're going to be multiplying by the frequency. And then on the bottom, we're going to be dividing by the summation of frequencies. In other words, that's just going to be all the frequencies together, or the number of pieces of data that we have. So to do the midpoint to start with, what we do is we have to add the lower limit to the upper limit and then divide by 2. So what we're looking for is halfway between 0 and 49. And we can do that. Again, I'm just going to use my calculator here, hand, and not show it on the screen here. 0 plus 49, and we do get 49. And if we divide by 2, we're going to get 24.5. And then if I add 50 plus 99 and divide by 2, we get 74.5. Now remember, something else we can do here is, if we use the class width, we can actually move from midpoint to midpoint. So if we subtract the lower limits, so notice how if I go 50 minus 0, 50 minus 0 would be 50, or 100 minus 50, I get 50, or 150 minus 50 would give me 50. What this tells me, to move from class to class to class, you have to add 50. If you notice over here, 24.5 to 54.5, that's a difference of 50. So we can move from midpoint to midpoint to midpoint by just simply adding 50 each one. So I'm going to pause a moment and go ahead and add 50 to each one of those. So I've completed my midpoints. So notice that 24.5 does look halfway between 0 and 49. 74.5 does look halfway between 50 and 99.5. If I go way down to the bottom here, 400 to 449, notice that 424.5 looks like that's halfway. So those are our midpoints. So again, to find the mean, we have to do the summation of those midpoints. So I have to add all those together. I'm sorry, I have to do the summations of the product of the frequencies and the midpoints. So I actually have to multiply the midpoint and the frequencies together. So I have to multiply the 24.5 times that 41. So if we do that, we get 1004.5. So then if I multiply 74.5 times 9, I'm going to get 670.5. So again, I'm going to pause my video and do those calculations and see what we can come up with here. So as we continue on, notice that again, when you multiply 1 times the 274 or 224.5, also multiply by 1 does not really need a calculator. Also, when you multiply by 0, 0 times 324.5, when you multiply by 0, the answer is always going to be 0. So some of these you really don't have to use a calculator for. So my next move is I have to do the summation of these here. So I have to add all these values together. So I'm going to take a moment and do that. So I'll be right back. So when I add all those values together, I came up with 4,768. So to find the mean, I still got to divide by the number of entries. Notice that there were 41 entries in this range, or we had 41 of these 24.5s. We had 9 74.5s. We had 6 124.5s. We had 2 174.5s. So notice, just looking at this, the bulk of the entries are really up here. So again, this value of 24.5 and 74.5 and 124.5 are going to be carrying a lot of weight since there's so many of these. So I have a feeling when I do the mean, it's going to be more like down this range as opposed to way up here around 424, because we didn't have that many up here in the upper area. So the bulk of the data based on the frequencies are here in the top part of it all. So again, to find how many actual frequencies there were, we have to add those together. So 41 and 9 would be 50, 56, 58, 59, 61, 62. Looks like I have 64 entries or frequencies, repetitions. So if we double check that, 41 plus 9 is 50, 56, 58, 59, 61, 62, 64. That's the catch with a lot of this data when you do it by hand is it's so easy to make a mistake. 4,768, we're going to divide that by 64, hit enter. And this gives us then the 74.5 as our mean. So notice that again, it did appear actually right up here in the middle of all this. So that's what I was kind of expecting. So that's part of it all as well as you do this, is you want to kind of look at the numbers and pay attention to what they're doing. So that's how you would find the mean of a frequency distribution. So when you have these classes, you have to find the midpoint of the classes first, and that's where you have to add the lower limit to the upper limit and divide by 2, and that's where these values came from. And then if you notice that the class width was actually 50, I can use that class width to save me some time. Instead of trying to find the midpoint of every one of those all together, I can take kind of a shortcut there.